So this time we are looking at factoring the difference of squares. And this is another special example. I would say it's probably even more special than the perfect squares example we saw previously, because the actual factoring process is a lot more involved, because we actually need to do something to prepare it so we can factor it as we normally would. And so far, when we've been looking at our various trinomials that are ax squared plus bx plus c, we've seen two of the three different trinomials when either a, b, or c is equal to 0. One of them is sort of the silly example when a is equal to 0, because if you have a equal to 0, you're left with bx plus c, which, if you remember, looks quite suspiciously like a straight line. And that's because it is. And we worked extensively with straight lines in the first semester. And this is not a particularly interesting example because there's not really any factoring to do. We have also seen earlier c is equal to 0. And that gives us ax squared plus bx. And in this one, you can always factor an x out because both of them have one x attached to them, at least one x. And oftentimes you can also factor something that's a common factor of both a and b. But that's not really an especially interesting factoring problem. And today what we're learning about is what happens when b is equal to 0. And that gives us ax squared plus c. So we're going to look at an example of where b is equal to 0. And this example is 4x squared minus 25. And we're asked to factor this. And you're probably looking at this and saying, well, I can't factor anything out because 4 and 25 don't share any factors. And this doesn't look like factor by grouping. I mean, I don't have a b. What am I supposed to do? Well, what you're supposed to do is you're supposed to fill the b in and then proceed as normal. And this is probably going to seem pretty unnatural, but we're going to go ahead and write b in because we know what b is. B is 0. So I'm going to say that this is actually equal to 4x squared plus 0x minus 25. And the 0x there's a stand-in to tell me, okay, that's what my b value is, because I'm going to factor this by grouping exactly the way I did before. So we need to figure out our a, b, and c. Well, b is 0, as we previously discussed. A is 4, that's the number attached to the squared term, and c is negative 25. So we need to find our a times c, and a times c is 4 times negative 25, which, if you need a calculator or you want to calculate in your head, you might want to pause, but it equals negative 100. And b is, as we previously discussed, 0. So at this point, we now need to start thinking about the factors in negative 100, because we need to find something which multiplies to negative 100 and adds to 0. So the type of numbers which multiply to something and add up to 0 fall into a very specific category. Like the pair of numbers which add up to 0, they must necessarily be opposites of each other. So like 5 and negative 5, or 200 and negative 200, or 3 and negative 3. So we're looking for something like that with negative 100. And if you think about positive 100, you'd say, oh, well, 10 times 10 equals 100. But since this is a negative, I can say that 10 times negative 10 equals negative 100. And as should be pretty obvious, 10 plus negative 10 is equal to 0. So when you're going through and doing problems like this, you will always end up with something like this. These two numbers you're going to choose to split your b term with are always going to be the same, just with opposite signs. So now we can go ahead and actually do the factoring by grouping. So we have our 4x squared still, that's fine. And then we have plus 10x minus 10x minus 25. Now, before we move on, I just want to emphasize this again. these two statements right here are equivalent to each other because 10x minus 10x equals 0x or 0, meaning we don't actually need to include it right here. So 4x squared plus 10x minus 10x minus 25 is equal to 4x squared minus 25. From here, we can now get on with the factoring by grouping. So between our first two terms here, we can pull out 2x. When we pull a 2x out of 2x squared, we are left with 2x. 2x times 2x is 4x squared. And then when we pull the 2x out of 10x, we are left with 5. Now, when we have the negative 10x minus 25, you look at this and you say, okay, what goes into both negative 10x and negative 25? Well, we can't get any x's out, but if we look at that, we can say, well, 5 divides both 10 and 25, and they're also both negative. So I can grab a negative 5 out of these two here. And then negative 10x divided by negative 5 leaves us with a 2x. And you can also think of it in reverse. What times negative 5 do I need to get in order to get negative 10x? So that would be a 2x. And then from negative 25, we're left with a positive 5, as 5 times negative 5 is negative 25. And just as before, when we were working with factoring by grouping, we are once again left with the same thing inside our parentheses here, which is exactly what we needed. So now we get to factor those things out, and we're left with 2x plus 5 times 2x minus 5. And this is our solution at the end. And this also brings us back to the title, difference of squares. I mean, for one thing, if we look at this, these terms are actually both square. 4x squared has an obvious root, and negative 25, while technically not having a real square root, if you think about just 25, it has a real square root at 5. So this is the literal difference of squares. The 4x squared is one square, and the 25 is another square. And when we look at our answer, when we have a difference of squares, the answer is always going to look something like this. So the x terms are the same between them, and the negative, or the number, which is attached to the x inside the parenthesis, is also the same, only the sign on it is different. And in truth, every single time you come across a problem that looks like this, that has only the squared term and the number at the end, so where b is equal to 0, you're always either going to get an answer that looks like this, or there will be no real solution. There will be no way to factor it. All right, that covers difference of squares. So in summation, remember, when you have a difference of squares, b equals 0. So go ahead and plug it in and then factor it as normal.